Welcome to my new office. This is a decently sized bedroom in our house. It's not my new studio, that is the garage downstairs. That's going to take some time to get set up how I want and to do it right. So we intend to build out this office into a space that I can film videos and get back to doing live streams with much quicker. We do have some big plans for this space though. That said, there is a big problem with this space right now. You see with my computer in here that I used to edit videos, do CAD work, and live stream from, just 2 studio lights and just 2 3D printers running, which is nowhere near what I would like to have going in here. It is 91 degrees Fahrenheit in here right now. This isn't just about my personal comfort working in here, though I am a baby about the temperature. It's also about the equipment that I'm running. While I was filming this intro, I realized that the Prusa Mark IV was printing in thin air because it clogged. That was because it heat creeped. The first time I've seen that happen on that machine, because it's printing in the enclosure with PLA filament and it's over 90 degrees in this room, so it just overheated and clogged up. So what's the solution to this big problem? A big fan, of course. This is from AC Infinity. It's part of their Cloudline Pro series and it is a 12-inch inline blower fan. Whether or not this is going to solve my problem, I don't know. We'll go over the specs of it a little bit in a second. Now, this video is not sponsored by AC Infinity. They didn't send this fan over. A viewer did, actually. But this video does have a sponsor, and that is Brilliant.org. Brilliant is the go-to platform for interactive learning lessons on math, science, data analysis, programming, and even AI now. They've got courses designed to make it easy to fit into your hectic schedule and to do from just about anywhere, whether it be your hopefully not so hot office or on the go. What I love about Brilliant is how it transforms those everyday moments into opportunities to learn something new. Whether you're troubleshooting a tech problem or just taking a break, Brilliant offers quick, engaging lessons that fit perfectly into your day. If you're into data, maybe you're cataloging, I don't know, things like room temperatures in your office. Brilliant has excellent new courses on data analysis to help you take those data sets and really visualize and understand them in depth. From visualizing trends to making predictions, you'll be working with real-world data sets that can help you cool down those tough decisions. These aren't just random number sets you're going to be working with. These are coming from companies like Spotify and Starbucks. They are real-world applicable data sets that you can use to help you understand better. To try everything that Brilliant has to offer for free for 30 days, follow my link, brilliant.org/MandicReally, or you can click the link in the description. And if you decide to stick with the learning process, you can get 20% off of an annual premium subscription by following that link as well. Thank you to Brilliant.org for sponsoring this video. Now let's go talk about how that fan is going to help my office be a little more comfortable. First and foremost, let's talk about the why here. My office is on the 2nd story at the back of the house. The HVAC unit is here in the corner of the garage, which will become my studio. There's the air handler pushing air up through ducts throughout the house. And it is just a single zone, which means that this thermostat right here in the front room of the house is what controls the entire house's temperature. Meaning when the thermostat is set to 73 degrees right here, it could be 100 degrees up here and that thermostat's not gonna know any difference. And when you have a hot room like my office with a bunch of electrical equipment in it, it's really a recipe for disaster. When properly designed, this wouldn't be an issue, but I gotta work with what I have. Now, before anybody asks, this unit is working as intended. The problem is this house was built to McMansion standards, AKA build it big, build it pretty, cut corners wherever you can. I've already had an HVAC tech come out and take a look at it, and he agreed with my assessment. The intake return air to the output air, the differential is as it should be. It's getting cooled. The problem is, since it's a single zone and a single fan trying to push all that air around the house, it's a lot easier to push it to the 1st floor than it is up 20 feet into the attic and spread around to all the vents upstairs. Ideally, if I built this place, this unit would only be feeding the 1st floor and the attic would have a 2nd unit feeding the 2nd floor on its own with its own dedicated thermostat. At the very least, this should have been separated with zoning, but trying to retrofit that into the system really isn't going to do a lot right now. That's where our fan comes in. Airflow out of the register vents on the 2nd floor is pathetic at best with this current setup. On the 1st floor, nice strong airflow, it cools off relatively quickly. The second floor is just not getting the air pressure. It's getting lost in here. That's where this fan's coming in. It's gonna act as solely the dedicated fan for the second floor, so it can draw the cool air in and help push it up to where it's needed the most and equalize the two floors, hopefully. I wasn't intending to film this part of the video at this moment, but it just kicked on. I also have to deal with the noise of this thing in my studio. It's not the noisiest unit out there, but it's too loud for filming videos and streaming, so that's a whole nother project in the studio build out. But I'm worried about the fan that I'm installing in here adding to that noise. That's part of why I'm making this video, because I couldn't find the video that I wanted to see. When I was looking into this, I didn't want to be adding that additional noise to the system here, and all I could find was somebody powering this up on a workbench to show how noisy it gets. That is not indicative of how it's going to function in my application at all. I of course don't expect this to be a magic bullet fix just for my office. Clearly it's feeding the entire second floor. That said, the entire second floor is warmer than the first because of the deficiencies in the system. The master bedroom is anywhere from 5 to 10 degrees warmer than the first floor. One of the front bedrooms gets a lot of sun, and it's upwards of 15 degrees warmer than the first floor. My office just has the electronics to battle, and that's something I'm gonna have to worry about in the long run. If I can lower the overall temperature of the floor though, it will help my situation. Let's get spec sheet stuff out of the way. This is part of AC Infinity's Cloudline Pro series. It is a 12T model, so it's intended for 12-inch ducts like what I have for my main feed on that system. This is rated to 1604 CFM of output at 62 decibels of noise level. I'm hoping I can dial the speed down a little bit, still get sufficient airflow, and reduce that noise a little bit. That can be done on this because it's a PWM controlled motor in here, controlled through a digital display that can change various settings on it and reads out various temperature, humidity levels, a lot of stuff. And it also has Wi-Fi control capability. It can be plugged into the wall with a 110 volt outlet receptacle plug, really simple to at least power. This comes with a 2-year warranty and it retails for $399 US, which is why I was having a hard time deciding on whether I wanted to go with this or not. For that money, I could get a decently sized portable air conditioning unit to put into my office, but that wouldn't help the entire floor that is also warmer than the first floor. Which is why I need to thank Vitalii for sending this over to me. If anybody's familiar with building Voron 3D printers or modifying them, Vitalii produces high quality CNC components to upgrade and modify those machines, and it's thanks to him that I have this at all. I asked folks online about this thing, if anybody had experience with it. He had this one sitting in the box in his shop and provided it to me so I could use it for my application. Thank you to Vitalii, and you can find a link to his Etsy shop in the description down below. And I know I said all I could find was one of these things running on the bench, but I might as well show you what it sounds like running on the bench. Obviously, a lot of what you're gonna hear is the air flow through it. You may hear that once it's in the duct, we'll find out. I'm gonna plug it in. I don't have the controller hooked up right now, so it's just gonna ramp all the way up to full speed, which does mean that it can work without the controller. So I guess if that failed, it would default to full speed, not 100%, but here we go. I'm trying not normalize the audio any more than I normally would to like my speaking voice level. So let's go. With the benchtop sound test, the why of the project, and the specs out of the way, let's get this thing installed in here and see if any of this is worth my time. Obviously, I'm going to be cutting a section out of this 12-inch duct, so let's get stuck in. Obviously, first things first, I need to know how big of a section I need to cut out. This thing is just shy of 18 inches from end to end of the flanges, and I want to have a little extra wiggle room for the ducting I'm going to use to attach it. In my case, that's going to land right around 34 inches I want to cut out of that duct. First things first, I have to mark this insulation so I can cut it back. I'm going further than I need because there's going to be some flexible couplings on each end of this. We'll see when we get there. I don't want to totally remove this insulation if I can avoid it, so I'm just going to go ahead and cut a straight line down the front of it, and then cut around the circumference of the insulation so I can then peel it back like a banana and get access to the duct within. This is your friendly reminder that duct tape is not actually duct tape. There is specific duct tape. This isn't it. I need to locate where the fan is going to be so I know where to measure from and to. I have this HVAC unit very close to the duct, so I need to be sure that I put this in the right place. Luckily, that joint that was duct taped is going to be a really good place for the one end that'll save me one entire cut. To cut the other end, I'm going to use the greatest invention of the 20th century, the oscillating multi-tool. This thing makes pretty quick work of cutting the duct off, and then some hand snips to split it so I can actually get it out of this position. Don't worry, I did vacuum out all of the debris from inside of the duct. To install the fan, I need to remove the two band clamps that are around the motor housing. They hold it to the bell ends on this thing. So then I can get to the mounting screw locations on the bracket. To mount this thing, there's only one stud here and none of the holes were gonna line up with it. So I put a couple of 2x4s on the wall to screw to. Before I mount the bracket to those blocks, I've decided that I want some type of vibration isolation in this situation, at least something. So I'm gonna measure the holes on the bracket to see what size of like a rubber washer I can use in here. But because it's me and this is the MandicReally channel, I'm going to 3D print some using this Fiberlogy, the FiberFlex 40D filament that Prusa sent over with the Prusa XL. I haven't unboxed the XL yet, so I'm gonna use it on the Mark IV. I got it loaded up in there. To make these vibration isolators, I could jump into Fusion and I could design something up pretty quick. Or I could design it entirely in Prusa Slicer. That's what we're gonna do. So all I'm gonna do is right click on the build plate, add a shape, a cylinder. It comes in at 28.2 millimeters wide, and honestly, that is fine for what I'm going to be doing here. I'm gonna make it 7 millimeters tall. I want just over a 1/4 inch of thickness from this. Now to put the hole in the middle of it, all I'm gonna do is right click on the disc itself, hit add negative volume, once again a cylinder. This time I'm gonna make it 7 millimeters by 7 millimeters. And then I'm just going to put in the XY coordinates that are the middle of this disc. You can just pull up what dimensions it is, 125 by 105, do the same thing with the negative volume, and now I know that it's in the middle of that because the cylinder was created in the middle of the bed. And that is it. I've just created a 3D printable object totally in the slicer. Yes, it is very simple, but I don't need it to be anything else. Then I just need to send it to the printer. With my squishy, flexible vibration isolators that I made myself in hand, I'm ready for assembly. To have a flexible coupling on each end of this, I'm using this accordion stuff that has a aluminum lining that came from AC Infinity themselves. However, it's just under 12 inches on the inside diameter, meaning that there's quite a bit of cussing and a lot of fumbling around trying to get these installed onto regular 12-inch ductwork. I ended up slitting the pipes at both ends to squeeze them in just a little bit and reduce their diameter so I could get this slipped over. It worked, but it wasn't fun. To mount the bracket, I had those vibration isolators, wrestled it into place, and screwed it into the blocks that I put on the wall before. I also made sure to insert the temperature probe for this fan into the ductwork. I'll explain why in a little bit. Then I'm ready to actually install the fan, which is arguably the easiest part of this. With a little bit of planning for my routing of the cables, I can ensure that it's going to reach the outlet to my right there and that I know how things are going to route once I cable manage this. And that's the installation of the fan itself. I sealed it up with some foil tape that I had that's more so meant for the duct insulation, but it is rated to a high enough temperature that I'm not concerned about it. With everything sorted as far as installation is concerned, it's time to unpeel a banana, which was a very strange thing to do, but it did work out, and I was happy to see the installation actually covered this pretty darn well in the end. A little bit of cable management with some zip ties, and it's time to hook up all of our electrical connections, including plugging this in and firing it up. So with this thing installed, powered on, it's time to answer the $400 questions. How loud is it? And how does it work? Noise level is probably what drove me to make this video in its entirety, so let's talk about that first. Is it loud? It depends. This thing has 10 speed settings and you can set it on the controls or in the app to only go to a certain speed level. When it's on number 10, it's between 54 to 56 decibels. That's not that loud, but the sound quality out of it is annoying. For comparison, here's sound level 8. This was somewhere between 50 to 52 decibels of noise, but the sound quality is significantly different. When it's on 10, if I put my hand against the wall, I can feel the vibrations in the wall. On the second floor of the house, especially in the space that's directly above this unit right here, which is my partner Ruby's office, it's a weird sound that you can just hear throughout the second floor. My partner Ruby is particularly sound sensitive. Noise pollution grates on her pretty heavily. So a fan that I installed directly underneath her feet, coming and going throughout the day when it kicks off and on, it wouldn't be a good time. For my use case, I've landed on fan speed 7 as the best balance of airflow and noise. It comes in right around 47 decibels, without any particularly weird noise, and the air handler fan is louder than that and also has a little bit of a rattle noise to it. So the AC Infinity fan isn't really making this space that is my studio particularly loud. Before we get to talking about whether this thing's performing the way I want it to, let's talk about how I'm controlling the system so when the main fan kicks on, this additional fan kicks on without me having to do anything. Earlier, I mentioned that I stuck the temperature probe into the inlet side of the duct of this thing. The reason I did that is the controls here have a couple of different ways that they can actuate this fan built in. One of them is a low or a high temperature reading. When it hits a certain reading, it'll kick the fan on. I set it to 61 Fahrenheit, so when it detects the cool air coming from the air handler to the fan, it will kick the fan on automatically. Now, it does mean there's a bit of a delay from the air handler turning on to this fan turning on because it's got to lower the temperature on that temperature readout, and it doesn't happen instantaneously. In fact, while I tried to film this a second ago, it kicked on. So it took exactly this long to go from the air handler turning on to the AC Infinity fan kicking in. It also means that the fan continues to run after the air handler fan turns off because the temperature needs to come up for it to signal to turn off. I'm actually okay with that. I feel like it continues to push just a little fresh air to the second floor, and I don't mind it. What I want to do is set up an automation in Home Assistant so that that fan kicks on when the fan in the air handler turns on. I think this is doable, but I don't know the exact path to it just yet. I know I need to replace the thermostat for the air handler as it's not even Wi-Fi connected, but that's long-term how I want to handle this. For right now, the system is working as I have it set up. If you have any input on how I could set up an automation, let me know in the comments. Elephant in the room time. This whole thing started because my office was too hot. So after all this install, all the preamble here, how is it now? It's better, it's not great. But that's not the whole picture. Let's talk about the office first. This space, when I started this video, I had my computer stress testing at the time, studio lights, 2 3D printers running, but the air conditioning was on as it normally was, and it still reached 91 degrees Fahrenheit in here. But that was a different day. Now, when I went to do my testing, it's a little cooler outside. I still had my computer stress testing, the same stress test, and 2 3D printers running, but not the studio lights. It reached 88 degrees Fahrenheit in here. Now, I ran the AC unit 2 full cycles. So it turned on, turned off, turned on, turned off. Right when it shut off the second time, after it reached temperature downstairs, I checked the temperature in my office and it was 83.5 degrees. Yes, that is a almost 5-degree improvement from the air conditioning running, but that's still 10 degrees hotter than the thermostat downstairs set at 73. But in my opinion, just being in this space, feeling the airflow coming out of the ducts now with that new fan, it is better in here. It's just not as good as I need it to be. Again though, that's not the whole picture. There's more rooms on the second floor than just my office. This is my nightstand in the master bedroom, and that temperature is below the thermostat setting on the first floor while the AC is running. Previously, we had to turn the AC down each night so that the master bedroom would be comfortable. Now we're getting below the thermostat temperature on the first floor. That means I can actually turn the thermostat up at night and still have a comfortable temperature in the master bedroom, which should save me on energy bills and lifetime of the AC as well. For my office, there's gonna have to be bigger measures, but I do have one more thing I can do with the current setup to improve my space. That's called a jump duct. I'm not gonna do it in this video, but I will be installing one of these. It's where I cut a vent into the ceiling of my office, install flexible ducting up in the attic to another vent that'll be above the return air vent in the hallway of the second floor. Now this return is in the laziest place it could possibly be in this house, in the floor, in the hallway of the second floor, but it will allow this to more directly draw air out of my office and circulate the air here. This should help to improve the temperatures a little bit further. It's not gonna fix things though. I really need some supplementary system just to deal with the heat that I'm pumping into this room. Something like, I don't know, this 18,000 BTU mini split that I have right here. This is for the studio space, unfortunately. I ordered this before we arrived in Portland, so it would be delivered when we got here and I could get it set up in this space. It's taken longer than I would have hoped. And what I really should have done is gotten like a multi-zone system where I could have had one outside unit that would run the studio and my office. In the long term, that might be the answer, but there is negative budget for that right now. I'm gonna have to go get one of those portable air conditioners that sits in the room on the floor for my office. I am not happy about the noise that that's gonna put out, the space it's gonna take up, the power it's gonna draw from the room, but I really just don't have much other option to control that room, unfortunately. With those questions answered and a few more raised, I think it's time to call it on this project, folks. I hope somebody out there got some more information that I could impart to them about setting up one of these things. I'm impressed with it in some ways. I wish it had done more in other ways, but I kind of expected it wasn't going to. And for those of you who just enjoy watching projects get done, maybe you'll enjoy this video of putting together the network in the new house, or this video that YouTube thinks is best for you. Get subscribed to ensure your 3D prints don't fail. It's not a guarantee, but it can't hurt. See you, folks.